Hello everyone, I'm Zhang Fangwei from Beijing University of Posts and Telecommunications. And welcome back. In our previous lectures, we explored the three new drivers of the future: the new intelligent connectivity, the new smart manufacturing, and then the new energy. Together, these transformations paint an exciting picture of the future. Today, we are going to look deep at the critical pillar supporting all of this: the new materials industry. In China, new materials are often hailed as 国之大才, which means the great materials of the nation. They form the very foundation of manufacturing and serve as a bridge to future technologies. Virtually every field of modern industry depends on advances in materials science. As early as 2015, China released its strategic blueprint, Made in China 2025. One of its core objectives was to promote industrial upgrading, and the new materials were identified as one of the 10 key areas for prioritized development. The logic behind this is clear. Only by mastering the core technologies of critical materials can a nation ensure the security and the resilience of its industrial chain. To achieve this, China has focused on making traditional materials smarter, greener, and more efficient, ensuring self-sufficiency and security in critical materials for core industries, and developing next-generation materials that will define the future. First, let's take a look at the Fuxing high-speed trains racing across the vast land of China. They demonstrate to the world both the speed and the breadth of China's application of new materials in rail transportation. Driven by national strategy, they serve as a mobile laboratory running at the forefront of materials science. Let's start with the train body. To achieve extreme lightweight performance, Fuxing trains use large, hollow, and specifically shaped aluminum alloy profiles. This isn't ordinary aluminum. What makes it new lies in the limits of its manufacturing process. Imagine this: extruding aluminum alloy into giant tubes with intricate cross-sections and walls only a few millimeters thick, while ensuring perfect internal uniformity and strength. This represents one of the most demanding engineering challenges in the world. To overcome this challenge, China assembled a cross-disciplinary technical team, bringing together experts from relevant enterprises, industries, and universities. Through countless trials, they mastered the full set of core technologies like alloy formula, mold design, and precision extrusion, successfully building the Fuxing high-speed train's lightweight and ultra-strong aluminum skeleton. Building on its high-strength, lightweight aluminum alloy body, Fuxing trains also use carbon fiber composite materials in certain structural components. Carbon fiber composite materials are even lighter and offer superior flame resistance. They will not burn or release harmful smoke even when exposed to high temperatures or open flames. Carbon fiber, often hailed as the king of new materials and black gold, boasts exceptional performance. It has a density less than 1/4 that of steel, yet is 7 to 9 times stronger, and it also offers outstanding resistance to corrosion. Today, heat-resistant and flame-retardant carbon fiber composites have successfully overcome previous technical limitations and can be applied in subways, high-speed trains, and automobiles, providing an extra layer of safety for passengers. Now, let's turn our eyes to the sky, the C919. China's domestically developed large passenger aircraft stands as a prime example of the nation's push to achieve breakthroughs in critical strategic materials. A modern passenger aircraft is made up of millions of individual components. Among the primary materials used in the manufacture of commercial aircraft, aluminum alloys account for as much as 65%. The most important of these is the international third-generation advanced aluminum alloy, 7050 aluminum alloy thick plates. They are indispensable materials in the manufacture of critical components like wings and the landing gear. At the very beginning of the C919 project, however, the core manufacturing technologies for 7050 aluminum alloy thick plates have long been regarded by developed countries as highly confidential. These materials were not only extremely expensive, but also subject to frequent supply restrictions. Faced with this challenge, China chose the path of independent research and development. In 2005, an industry-university research collaboration was formed, bringing together the country's top engineers from within the industry and the leading experts from universities and the research institutes. The first challenge they faced was the difficulty of forming large-scale 7050 alloy ingots. This aerospace-grade material demands exceptionally high purity and internal uniformity. Any minute flaw can be fatal. In the early trials, furnaces of raw material worth hundreds of thousands of yuan were often rendered useless with a single sharp cracking sound. But the team didn't give up. During that period, they stood by the furnace around the clock from the very beginning of the casting process, waiting to observe the results after each smelting and forming cycle. After hundreds of attempts, through repeated testing, analysis, and process adjustments, they finally succeeded in overcoming the technical bottleneck of ingot cracking. Therefore, the C919 is so much more than just an airplane. It serves as a powerful engine of innovation, driving and cultivating an entirely new domestic supply chain for advanced aerospace materials, and ultimately achieving independent control over critical strategic materials. On the Fuxing high-speed trains and the C919, we can see how new materials make land and air transportation lighter, stronger, and more efficient. Next, let's soar into the vastness of space and see how China's manned spacecraft represent the nation's pursuit of the ultimate performance limits of new materials at the frontiers of science and technology. Let's take a look at China's new generation of manned spaceship Mengzhou, which is developed through a comprehensive upgrade from the Hangzhou manned spaceship. Mengzhou's re-entry capsule wears 2 layers of clothing. The inner layer, made of a new metallic material, functions like a wall, forming the astronaut's cockpit with excellent air tightness and minimal obstruction to their view. The outer coat, made of a new type of lightweight, ablative, heat-resistant material, is 30% lighter and more thermally efficient than that of the Hangzhou manned spaceship. We can say that aerospace engineering is a testing ground and an incubator for new materials. The cutting-edge materials developed for space exploration will eventually find their way into civilian industries, driving advancements across the nation's entire technological landscape. From high-speed trains racing across the land to spacecraft venturing into the unknown, new materials have reshaped how humanity moves and explores. Today, as the planet faces the challenge of global warming, these innovations are taking on a new mission: not to reach farther, but to sustain longer. Do you remember the 3 new drivers of the future we mentioned at the beginning? Among them, the new energy revolution, represented by photovoltaics, has become the cornerstone of the global green transition. At its core, this revolution is a revolution in new materials. A solar photovoltaic panel itself is a collection of advanced materials. It needs high-purity polysilicon with a purity level as high as 99.9999999%. Ultra-clear glass with extremely high light transmittance and strong resistance to hail impact, and the EVA or POE films to protect the internal cells and ensure stable performance for over 25 years in harsh outdoor environments. Over the past decade, China has invested enormous research and development efforts into these key materials and has successfully built the world's most complete photovoltaic industry chain. According to data from authoritative institutions, China now holds a dominant position in several key segments of the global photovoltaic supply chain. For example, it accounts for more than 90% of the world's production of high-purity polysilicon, nearly 98% of silicon wafers, and over 80% of photovoltaic cells and modules. This China contribution, driven by breakthroughs in materials and the large-scale production, has been the core driving force behind the more than 80% decline in global photovoltaic power generation costs over the past decade. It's helping deserts in the Middle East, villages in Africa, and the islands in Southeast Asia gain access to clean and affordable energy. Broadly speaking, if the Fuxing high-speed trains, the C919, and the manned spacecraft show China's efforts to achieve industrial upgrading, then in the field of photovoltaics, China's new materials industry is emerging as a powerful engine driving the global energy transition. From the cases we've discussed today, it's clear that new materials form the most solid foundation of new quality productive forces. They turn a nation's top-level strategies into tangible miracles of innovation. And more importantly, they embody the solutions China is contributing to the world, solutions that are more efficient, more accessible, and cleaner for all. Thank you for watching.